First lesson ever in this brand new pre-calc curriculum. So here we go. Let's get started. Like any good math book, they are going to put a foundation underneath you and expect you to build on it. And so don't let any of this stuff kind of get out of control. Make sure you understand it. I'm going to do my best to make it clear for you. First thing I want you to do is just take a look at your book. Look at page 7. There's about a dozen or so, 10, 12, 14 parent functions. A lot of those you've never seen before. Don't get too stressed about it. We're going to work with them. The idea is that you don't have those memorized, but the idea is to understand all the language that applies to those graphs. And you'll start to understand the graphs the more and more we use them. Now, having said that, we got to get that foundation for it. So here we go. Basic Math 101. This is like pre-algebra stuff. If y equals 2x plus 6, find y if x is 2. This is what we're going to refer to as our input, because this is what we know. And we're going to plug it in, so we get 2 times 2 plus 6 equals y. And so y is 4 plus 6, which is 10. This is what we found, so this is our output. So it's like putting a dollar into a pop machine. The dollar is the input, the x. The pop is the output, the y. Keep that in mind. Here comes the fancy talk now. Remember what we're teaching you. This is pre-calc, getting you ready for calc. Brand new language. Maybe you got a lot of this in your Algebra 2 course, so maybe this is like, oh, tell me something I don't know, but I got to go over this. So look at this. If f of x equals 2x plus 6, notice something? 2x plus 6, 2x plus 6. Find f of 2. F of 2, what does that mean? That means let x equal 2. Remember, x equals 2. And plug it into the equation defined by f. I know that sounds fancy, but here's f, and here's the equation defined by f. It's a new way of talking. Yes, it's making something very simple sound complicated, but it's the new language of calculus / pre-calc. So what is f of x? F of x is actually y. Now what about g of x? What about h of x? Every time you see this, feel comfortable substituting that either literally or mentally with the letter y. So this is y equals 2x plus 6. We're plugging 2 in for x. We get 2 times 2 plus 6. Look at this, guys. 4 plus 6 is 10. So we would say f of 2 equals 10. That's a fancy way of saying if x is 2, then y would equal 10. That's another way of just saying the coordinate point to 10. All right, that's a warm-up. Now I'm going to take that same function, same equation, y equals 2x plus 6, and we're going to consider what the graph of it is. But I'm going to also introduce you to a couple new terms that maybe they're new, maybe they're not. But if I was to graph this, this is an old school way of doing it. I could just plug -3 in here and figure out what that is. That'd be -6 plus 6 is 0. 2 times -2 is -4 plus 6 is 2. -1 times 2 is -2 plus 6 is 4. And I can see a pattern here, and I'm just going to go for it. So these are all of my points. Now, how many points do you really need? Well, you only need 2. But let's talk about this. This is a different way of saying this. Now remember, this is my input. This is my output. So this is just saying plug in f of -3. That's just what we did over here. So this will be 0. This will be 2. This will be 4. This will be 6, 8, 10, 12. So if I plug in x is 3, 3 times 2 is 6, 6 plus 6 is 12. This is the new fancy way of saying this. Now, these are all my inputs. These are my outputs. So my x is considered my input, which here comes some fancy talk. It's my domain. And then all my y's, they are considered my range. Now, I got to break something down for you. So here we go. if I was to plot all these points, negative 3, 0 would be right here, negative 2, 2 would be right here, and I really don't need to plot them all. Now, some of you are already saying, well, you're making this too hard. Well, I'm doing it for a reason. I know that this is my y-intercept, so I could just go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Looks like that needs to be up here. And then that would be my y-intercept, so my line would be like this. Now my slope is 2 over 1. So the way we used to do it, using y equals mx plus b, plot your y-intercept, and then slope is up 2, right 1. So up 2, right 1. My drawing's not perfect, but you get the idea. So this goes on forever. And so here's the big moment. If they said, looking at this chart, what's your domain? You would say, aha, that's my x's. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Now, if they asked you what's the range, I would say my list of y's. 0, 2, 4, 6, 8, 10, 12. However, if they said, hey, look at this picture, and then ask, what's the domain? You would ask yourself, okay, my domain is my x's. Remember, my x is how far to the right or how far to the left. Well, if this graph just keeps going this way, it's going to continually get wider and wider that way, wider and wider that way forever. So my domain would be x is greater than or equal to negative infinity, less than or equal to positive infinity. Now, what would my range be of this drawing? Well, how low? Remember, range is my y, so that's down, this is up. So the question is, you always start with how low it goes. How low would this thing get? Well, that'd be negative infinity, so y is greater than or equal to negative infinity, less than or equal to positive infinity. So there's a difference. If you're finding the domain of a chart, you got a set of numbers. If you're finding the domain of a graph, you got to think bigger than this. Because remember, there's an infinite number of points on a line. It continues left forever, right forever, down forever, up forever. And that's why these are your real answers for domain and range. Okay, let's pause right there. All right, so we're going to transition. Last example was a linear function because it resulted in a line. This is called a quadratic. Now, don't be fooled. You go out and ride your quad. You got 4 tires on that bad boy, so the number quad makes you think 4. But in this case, it's a strange connection. It's just saying that your highest power is 2. So you'll get used to a quadratic always being a parabola. Now, I already plugged in these numbers. Negative 3, if I plug it in, this is my input. If I plug it in, that's negative 3 squared is 9, negative 2 squared is 4. I think you guys get the idea. 0, 0 is right here, and if I go negative 1, 1, it'd be negative 1, 1, 1, 1, 2, 4, negative 2, 4, and there it is. Okay. Now what I want to talk about is, what is the domain of this graph? Well, how far to the left does this go? Well, it goes forever, so x is greater than or equal to negative infinity, squeeze that in there. How far right does this go? Well, it continues to get wider. I know you want to look at these arrows going up, but you have to think left and right when you're thinking domain. So that would be positive infinity. Now here comes a little difference. Range. Remember, always start with how low it goes in your mind. Well, how low does this go? Well, it gets down to 0. Think of it in degrees, like the y-axis is like a temperature. It gets down to 0 degrees. And then it goes up forever. How do I say that? Y is greater than or equal to 0. There'd be my range for that drawing. A little different. All right, the next thing I'm going to explain is kind of hard to wrap your brain around, so hang in there. They're going to ask you about these graphs. Are these graphs considered a function, or are they not considered a function? Now, the reason it's confusing is because when I see any equation, I'm going to call it a function. I'm going to call that a function. And the math books do too. But then there's this definition of what a function is, and we have to actually fine-tune our thinking. And the definition of function is for every new x, there's going to be a new y. I want you to notice, don't they have the -3 corresponds with 9, the +3 corresponds with 9. Because there's a match in the y's, and notice the 4's match, the 1's match, this is not what's defined as a function. Now look at the linear equation over here. Every single y is different. So we would say, yes, this is a function. When they ask you specifically, is it a function or not? Now, there's a really easy test for this, and it's just called the horizontal line test. You just throw a horizontal line, and look at it. This hits it in 2 places. That means it is not a function. I can put a horizontal line anywhere on this line, and I'm only going to hit it 1 time. That's why that's a yes. Or you can just look at the information. If you have matching y's, it's not a function. So there's a little strange definition. Another thing they're going to ask us about is, all right, after you've taken a look at the graph, what's the x-intercept? What's the y-intercept? I'm going to start over here. And the y-intercept is simply where the graph crosses the y-axis. So in this case, that'd be 0, 6. In this case, that'd be -3, 0. I want you to notice something for future. The x-intercept, y equals 0, because it's not above the x-axis and it's not below. The y-intercept, x equals 0, because it's not to the left of the y-intercept, it's not to the right of the intercept. So that's a little twist. This one here, that one right there, is both the x-intercept and the y-intercept. So that would be 0, 0. Pretty simple stuff. Okay, just some basics that we gotta know. How do you graph x equals 2? Well, if x equals 2, then look at x has to equal 2. So it doesn't matter what I put in for y. 2, 1, 2, 2, 2, 3. This is a vertical line. So all x equals are vertical lines. How about this one? Well, if y is 2, y has to be 2. If I put any x values in there, I get 1, 2, 2, 2, 3, 2. Notice horizontal line. So y equals horizontal. X equals vertical. Just gotta know it. Here's a twist. X equals crosses the x-axis. Y equals crosses the y-axis. Another memory tool for you. So part of your assignment and your expectation to understand something, and this is going to be a common theme throughout this whole trimesters, what the heck is an asymptote? An asymptote is a vertical line or a horizontal line that's got kind of, I call it a gravitational pull. You see this graph? It wants to go and it wants to touch this line here. Now remember, this is y equals 2 because it's a horizontal line and it crosses the y-axis right at 2. So that's the asymptote's name. So if a graph wants to approach it and it just keeps getting closer and closer and closer, but it never crosses this line, it's called an asymptote. So this graph right here definitely goes down to here and touches it. This is not an asymptote. Notice the difference? Gravitational pull just goes down and goes up. There's really no asymptote here. We'll work with that more. All right, one more thing. Line of symmetry. Definitely connected to this and this. So a line of symmetry is a vertical line or a horizontal line that cuts a graph right in half. So the halves are mirror images. I look at this parabola and I cut it in half. That would be the line of symmetry. What's its name? X equals -2. Why? Because it's a vertical line, and there it is. X equals -2. Now, does this one even have a line of symmetry? No, there's no way you can cut this one in half. So they don't all have lines of symmetry. So that finishes your first pre-lesson. Now, don't think your pre-lesson gets you all set for your homework. It's just kind of to set the table, so then you can have a feast. The next video, don't skip it, are my example problems, which will help you kind of see what the homework expects of you.